Today we're going to be looking at whether or not a trig function is odd. So the title of this lesson is Identify an Odd Trigonometric Function. We're going to be doing it analytically or algebraically. So in other words, does f of negative x equal negative f of x? Another way to put it, does f of negative theta equal negative f of theta? We did odd functions a long time ago when we did the beginning of this course. Now we're looking at trig functions and proving if they are odd or not. Now do not forget these odd identities for trig functions. We know that sine and cosecant are odd, meaning sine of negative theta equals negative sine of theta. And the same for cosecant, and tangent and cotangent are also odd. Tangent of negative theta equals negative tangent of theta, so on and so forth. We said that cosine and secant are even. Now, as we learned in the even function lesson, if you change what's inside of the parentheses or add something on the outside, that might change whether or not it's even or odd. For example, we saw that there was a variation of sine that was even in the last lesson. So be careful. Make sure you go through these steps in order to get the right answer. Once again, here's our definition of what makes a function odd. When you plug in a negative number, you get the same thing back as if you make the whole function negative. We say that that function f of x or f of theta is odd. So let's jump right to example number 1. We have f of x is equal to 4 cosecant of 3x minus 2 pi. The question we're going to ask is, does f of negative x equal negative f of x? In other words, when you plug in a negative number, do you get the same result as when you plug in the positive version of the same number and make the function negative? Here's some examples of what a odd function looks like on a graph. There is some diagonal symmetry going on. We will look at the graphs of these when we're done and see if we can notice that symmetry. There's also another way to tell, which we'll talk about graphically in a little bit. Step 1 for determining whether a function is odd, simplify f of x if possible, just like we did in the even function lesson. So the question is, can you simplify 4 cosecant of 3x minus 2 pi? Well, I want you to notice right here, what happens if you subtract 2 pi from an angle, especially in regards to the unit circle. For example, let's say we were at pi over 3. If we subtracted 2 pi, we'd be going 360 degrees clockwise, and we'd end up at the same angle. If we were at 3 pi over 4 and so we subtracted 2 pi, we'd end up at the same angle. You're going to end up at the same angle no matter what when you subtract 2 pi, which means the trig values are going to stay the same at that particular angle. Therefore, no matter what the trig function is, in this case cosecant, if we're subtracting 2 pi from 3x, okay, so for example, let's say x, well, it doesn't actually matter. Let's just say 3x is some angle, right? If you subtract 2 pi from it, it's going to remain the same angle, 3x. So we're going to simplify this off the bat and say that 3x minus 2 pi is just 3x. If it were plus 2 pi, it would also remain 3x. So it's very important to simplify first because you're working with a simpler f of x function. So now we have 4 cosecant of 3x. Step 2 is going to be to plug in negative x. So there's two things you have to do for odd functions. You have to plug in negative x and you have to figure out negative f of x, which we'll get to in just a second. So f of negative x, we're going to plug in negative x into our simplified function, so negative x are here. Step 3 is going to be to simplify that, so we can go ahead and pull the negative out right here. Should have drawn an arrow there. We can take that negative and put it in front of the 3. And then we can take the negative and pull it out again into the front of the function. Now, why can we pull the negative out from the cosecant? Because cosecant of negative 3x is the same as negative cosecant of 3x. And that's because cosecant, where are we at here? Cosecant is an odd function. So cosecant of negative theta is equal to negative cosecant of theta. In the same way, cosecant of negative 3x is equal to negative cosecant of 3x. And instead of putting the negative right here, we can just pull it all the way out in front of the 4. And that's because of the basically the commutative property, right? It doesn't matter which order you put the negative. We could put the negative over here and multiply by negative 1, right? But we're going to pull all the way out in front of the entire function. So now we have f of negative x is equal to negative 4 cosecant of 3x because cosecant is odd. And that also illustrates why step 1 is important. Get rid of that 2 pi because it just simplifies the whole thing. Step 4, as I said before, is to determine negative f of x, so just put a negative in front of the function itself. And again, we're working with the simplified version, so we're just going to put a negative out in front of both of these. And really, as step 5, you want to simplify that if you can, but there's really nothing to simplify, so we've just shown that negative f of x is equal to negative 4 cosecant of 3x. Step 6, we want to compare our two results. We want to compare f of negative x to negative f of x. In other words, you want to compare steps 3 with step 5, your simplified versions of those two things. And as you can see, f of negative x and negative f of x are the same thing. They're both negative 4 cosecant of 3x. Therefore, we've just proven that f of negative x equals negative f of x, so therefore f of x is indeed an odd function. In other words, our original function, 4 cosecant of 3x minus 2 pi, is odd. Let's take a look at the graph. Here's the graph of 4 cosecant of 3x minus 2 pi. You might not be able to tell graphically that it's odd, but let me give you another way to tell graphically if something is odd. This is something we talked about before in this class. If you flip this function vertically, okay, you will get the same exact graph as if you flip it horizontally. The other way to say it is if we flip it horizontally and then if we flip it, well, actually the order doesn't matter. If we flip it vertically and then horizontally, you'll end up with the same graph. So let's just focus on one of these u's. If I take this u and flip it, it's going to come down here, right? Okay? And if I flip it again, it's going to end up over here. And all of these u's will end up mapping on themselves if we flip them both ways. And therefore, that's a graphical confirmation that this function is odd. That is it for this particular example of determining whether or not a trig function is odd. And if you have any other questions about this, let me know.